Hello everyone, myself Raiyan Baig of Mechanical Department from ISL Engineering College. Today I'll here to discuss about the limits, fates and tolerances. Now let we begin. First, what is limit? The maximum and minimum permissible size within which the actual size of the component lies are known as limit. Or we can say it is the maximum and minimum variations that can be given to the size of the component which lies within the actual size. Now next we will discuss about types. There are two types of limits: upper limit, which is also known as maximum limit. Next one is lower limit, which is also known as minimum limit. Now we will discuss about limit with the help of example. Let us take an example of the shaft, which is having the basic size 25. To this basic size there should be some tolerances and limits should be given so that the component can be useful. So you can see here, this is the upper limit, which is greater than basic size, and the lower limit, which is within the upper limit. Let us take the basic size and the tolerance given to the shaft are 25 plus of 0.18 and plus of 0.10. For this shaft, the lower limit is equals to 25.18 and the upper limit is 25.10. These are the two limits that are given to the shaft which is having the basic size of 25. Now we coming to our next topic, that is fits. What is fit? Fit, as we all know, when we manufacture the different components in the parts, they are to be assembled. For assembly, we need to mate the parts with one another to get the required component. So the relationship between the mating parts that are to be assembled, that is, we can say hole and shaft, with respect to difference in dimensions is known as fit. As you can see here, we are making two parts, that is hole and the shaft. According to assembly, there are two parts that can be assembled, that is male and female part. Here we are taking hole as a female part and the shaft as the male part. When we assemble both the parts, we will get the required type of fit. Now we will discuss about the types of fits. There are three types of fits. First one is clearance fit, the second one is interference fit, and the third one is transition fits. Now we will discuss all the types of fits one by one. First, clearance fit. Clearance fit. When the largest permissible diameter, that is the lower limit of the shaft, is smaller than the diameter of the smallest hole, that is lower limit, then the type of fit is known as clearance fit. Now we will understand the clearance fit with the help of the example, that is hole in the shaft. Here in the figure you can see this is the hole in the shaft. This is the variation or clearance that is to be given while mating the parts. So this small variation of the clearance is known as positive clearance. It has given between the largest dia of the shaft and smallest dia of the hole. Dia of hole. This type of fit is known as clearance fit. It is also known as positive fit, and this fit is given for relative motion between the two mating parts. For example, shaft rotating a bush. It is an example of clearance fit. Now second one, interference fit. Whenever the minimum permissible dia, that is the lower limit of the shaft, will exceed the diameter of the maximum dia of the hole, then the type of fit is known as interference fit. Now you can see here, this is hole and this is the shaft. Here the small clearance is given between the upper limit of the hole and the lower limit of the shaft. It is also known as negative fit, and it is permanent fit, and there is no relative motion between the mating parts. Relative motion between the mating parts. Now we will we'll take the example of now we will go to the next type of fit, that is transition fit. Transition fit. In this type of fit, the diameter of the largest allowable hole is greater than the largest shaft, but smallest hole is smaller than the largest shaft. In simple words, you can say it is the combination of both clearance and interference fit. Clearance and interference fit. As you can see here, the hole in the shaft. Here both the positive and negative clearances are present. So transition fit provide both negative and both the types of fit, clearance fit and the interference fits. Now we'll move forward to our next topic, that is tolerances. For example of this transition fit are coupling ring, I also forgot to give the example for the interference fit. For the interference fit, example is bearing bushes, keyways. These are the examples for the interference fit. Now we'll continue. What is tolerance? What is tolerance? As it is impossible to make anything to an exact size, it is essential to give or to allow a definite tolerance, or we can say variations, on every specified dimensions, so that we can assemble those parts easily. It is known as the total variation given to the component, or you can say it is given by, tolerance is given by difference of upper limit and the lower limit, and the tolerance will always be positive. For example, the basic size of the shaft is given and the upper limit and the lower limit are given as 0.18 and 0.10. So we can calculate tolerance. Tolerance is equals to upper limit minus lower limit. So upper limit is given as 25.10 minus 25.18 minus 25.10. So the required tolerance can be calculated from this formula using the upper limit and the lower limit. Now we'll move forward to the type of tolerances. That is the last topic. Now the first type of tolerance is unilateral tolerance. What is the unilateral tolerance? When the two limit dimensions are on one side of the nominal size, that is, when the two limits are given either the above or below the nominal size, then that type of tolerance is known as unilateral tolerance. For example, basic size of 40 with a upper limit as 0.02 and the lower limit as. These are the examples for the unilateral tolerances. Here both the limits are above the nominal size or below the nominal size. Now next type of tolerance is bilateral tolerance. Now what is bilateral tolerance? When the two limit dimensions are given above and below the nominal size, then this type of tolerance is known as bilateral tolerance. For example, 25 plus or minus 0.02, or you can say 40 minus of 0.01 plus of 0.02. Here the limits are given both above and below the nominal size. Whenever this type of limits are given, it is known as bilateral tolerances. Okay, that is two of our topics. I think I have covered all the topics. Limit, what is fit, limit, fit and tolerances. I hope you have understand the topic what I have explained you. If you have any doubt, you can clear with me. Thank you.